guys, so today's problem is gonna be problem 2751, robot collisions, and it's gonna be the first hard problem of this month. Um, so I'm just gonna read the problem right now. There are n one-index robots, each having a position on a line, health, and a movement direction. You're given zero-index integer arrays, positions, healths, and a string directions. Directions I is either L for left or R for right. All integers and positions are unique. All robots start moving on the line simultaneously at the same speed in their given directions. If two robots ever share the same position while moving, they will collide. If two robots collide, the robot with lower health is removed from the line and the health of the other robot decreases by 1. The surviving robot continues in the same direction it was going. If both robots have the same health, they are both removed from the line. Your task is determine the health of the robots that survive the collisions in the same order that the robots were given, i.e. the final health of robot 1 if survived, final health of robot 2 if survived, and so on. If there are no survivors, return an empty array. Return an array containing the health of the remaining robots in the order they were given in the input. After no further collisions can occur. Note, the positions may be unsorted. Okay. So we have an example here. All the robots are moving in the same direction. So the input is positions, 5, 4, 3, 2, 1, healths, directions, and the output is going to be the exact same thing as the original healths, the health that was given. Uh, okay, and then the second one, positions, is 3, 5, 2, 8, health is 10, 10, 15, 12, directions is RL, RL, and then the output is only 14, because 14 is the only robot that survives, or 14 is the health of the only robot that survives, which is robot 3, this one. And then finally, we have positions, 1, 2, 5, 6, blah, blah, blah. And then no robot survives, so it returns a blank array. And finally, for the constraints of the problem, the length, or like the number of robots, is less than or equal to 10 to the power 5. And the positions are in the range of 10 to the power of 9, and so are the healths. Okay, so I think this hard problem is actually kind of easy as far as like hard problems go, because all we have to really keep track of is like the health of the robots in the end, right? Instead of, we don't have to like look at the positions of the robots or anything like that. We just have to keep track of the health. And we already know, we can easily tell which robots can collide because two robots only collide if they're going in the different directions, and like the second robot, okay, like they're going in different directions and they're moving towards each other. For example, the one that's going right is has a position, an initial position that's less than the one that's going left, right? And so that means we don't have to worry about something like they're going in the same direction but different speeds or anything like that, which I think makes the problem a lot easier. Um, and the main thing in the problem is just like keeping track of all the mappings, because like we gotta return the healths of the robot in the specific order they were given and all that, which is kind of annoying, but yeah. So I think we could do like a stack based solution. So for example, for the first example, right? Let's say we have 10 on the stack. We start from left and we move right. Oh, I guess example 1 isn't a very good example because no collisions happen. So let's look at example 2. So first we push on this robot 15. We start from left to right and we push, since these robots are going to the right side, that means we can probably just like push them on the stack. And we want them on the stack to keep track of when a robot going left occurs, to look at their collisions, right? So we can do 15, then we put 10 on the stack, and then 10 from the other direction happens. So then we have that these two robots destroy each other. So now we only have 15 on the stack, and then we put on 12. We have that 12 is less than 15, so we just replace 15 with 14. And let's say instead of 12, the robot going left was a 20, right? We would remove 15 from the stack, because 15 is less than 20, decrement 15 to 19, or decrement 20 to 19. And then since 19 is a left going robot and there's no robots left on the stack, we know that this robot's going to be a robot that definitely survives. So we can just, we can just, oh, we can have like another array or something like that and just like put that robot, keep track of that robot's health on that array. Okay, so I was gonna say like we could just push this onto the answer array, but we also have to keep track of the order for the end. So we can just have a whole array to keep track of the end healths, or like the resulting healths. And then for any resulting health that's not 0, we go through in the original order, and print it. Okay, so that's how I think the solution's generally going to go. It's definitely going to be an O of n time, because we're going through the array in like linear order, and the only thing that we're doing on each step is manipulating the stack, and all we're doing for each manipulation of the stack is removing elements, and at most the stack could have n elements go through it anyway, so that's also a linear time operation, like in total over among like the existing elements. So it's definitely a linear time a linear time algorithm. Okay, let's think about how to write this though. So we want to first sort everything by position, but we also want to make sure to keep track of the end. I guess we could just have like a really big tuple, like multiple zips. Okay, this might be extremely ugly, but here, let's do this. Oh, and I don't think the fact that the robots are 1 indexed really does anything in this problem, because all we really need is like the order of the robots. It doesn't matter if the order's 0 indexed or 1 indexed. But we'll see, maybe something comes up. Alright. Oh man. Okay. Robots is equal to, and then we want it to be sorted by positions. So we first do positions I for I in range. Positions I, then healths I, then directions I, then I itself to keep track of the robot's index. And then we do for I in range length of positions, let's say. Okay, I'm not gonna lie, this is kind of janky. So I'm just gonna print this out just to make sure everything is working correctly. and we can have some random output. Let's see, return an empty list. No, the syntax is in fact invalid. Oh, probably shouldn't have this comma. Let's try it again. Dang, my Python list comprehension is simply not on point. Man, should I just zip everything together? I think that would be very ugly though. Or it wouldn't really work even. Oh, okay, I was thinking about this wrong too. Let's try like this. So everything's in a list, and then each entry in the list is a tuple. Okay, this is right. Alright, so then we can have like a how should I name this? Like the resulting health array. Uh, yeah, I'm just gonna name it like H or something. We do H is equal to 0 times length of positions. Alright. You can also do robot.sort here. Now, let me print this out one more time. Make sure it's working correctly. Yeah, 1, 2, 3, 4, 5. Okay. Alright. I'm gonna do for robot and robots. If robot, let's see, directions is what, 0, 1, 2, since the second one is equal to, if it's going right, so if it's equal to that, then we can simply push that robot onto the stack. We can just do stack.append, and we really only need the robot's health, so we do robot 1 and the robot's like index, so 0, 1, 2, 3, robot 3. Okay. Else, while stack, so while there's robots on the stack, so stack, let's see, there's 3 possibilities. Okay. First, let's say the last robot on the stack has a greater health. So 0, 1. Okay. Has a greater health than the current robot's health. So we do robot. Oh wait, no, stack it's gonna be okay. The items on the stack are gonna be health and then index. Am I making this too complicated by doing that? Maybe we should have just pushed the entire robot tuple on. Oh well, doesn't really matter. So if stack, the last item on the stack has a health that's greater than the current robot's health, then we can just do it just goes down by 1. And our current robot, so our current robot's health is going to be 0. So we can just do h robot 0, 1, 2, 0, 1, 2, 3 is going to be equal to 0. And we know this isn't going to be 0, right? Because, hold on, I'm pretty sure all the healths are going to be non-zero. Yeah, all the healths are non-zero. So if the health of this is greater than the health of this robot, then that means this robot's health has to be at least like 2. So this has to be non-zero. Elif stack -1, 0 is smaller than robot 1. Oh, and we should also break out of the stack here. Or we should break out of the loop. Okay, so elif stack -1. Okay, else is if the last robot on the stack's health is less than this robot. Okay, so we can just do h stack.pop and then the robot's index is gonna equal to 0. Yeah. And then our current robot 1 minus equal to 0. Or minus equal 1. So the health of our current robot goes down by 1. And then we don't break here because we still have to consider the rest of the robots on the stack. Okay, you know what? If we're manipulating the robot's health like this, I guess it should not be a tuple. So else. So in the last case, that means that the last. Okay. That means they're both gonna die. We can just do this. Hmm. Okay, maybe it's easiest to. H equal to healths in the beginning. Okay, maybe we don't even need an H. We just use healths. That way we don't have to do anything after the loop. Because if all the robot's initial health value is equal to their actual health value, then we only have to keep track of like okay, then we would probably have to do this too. You know what? Maybe I'm doing this the wrong way. We don't need to keep track of healths at all inside the robot tuple. Because we just need to keep track of I and directions. Because then we could just use I to query healths, the array, and then find out the robot's current health. You know what? I'll just change my code to match that. And we don't need the directions either, because we could just, again, use... We really just need to sort I in respective positions. Okay, whatever. How would I even do that? Should I even go through the trouble of re-implementing that? Okay, you know what? This video is already kind of long, so I'll just rewrite it and then I'll cut the video back together. Or I'll stitch the video back together. I'll re-record it. Or no, I won't re-record it. I'll add... I'll skip it. I'll skip the rewriting step. Okay. So I just fixed everything, or I rewrote everything. Just to do a quick overview, I decided just to keep track of the robot's positions, or like not the positions, the indices, and then I just sorted by position in the beginning using lambda, and then I go for R in robots, and for like directions, I just query directions using R. For healths, any health related stuff, I just query the original healths array with like the index. So now stack is also only keeping track of index as well. So we just do da 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 da. I think it's pretty straightforward. All the underlying logic is the same, but yeah. We can do like an answer array. I'll just name it answer. Is equal to blank for age and health. Or is it healths? Yeah, it's healths. If age doesn't equal to 0, we can go ahead and append that to the answer array. And we just return answer. Let's see if it works. And it does work. I guess we can test like some edge cases. So let's say for example this one. But no, let's do a copy of case 2. We add something in position 1 with the health of 1 and it's going left. So in theory, this should not collide with anything. It works. What about something that's not going to collide with anything going right? Okay, I'm pretty sure the code works, but why not? So we do 1 R. Yep. Okay, I'm just gonna go ahead and submit this. Beats 88%. Am I the goat or what? Okay, wow, this looks very similar to mine. What's S? Oh, S is just their stack. Yeah, this is like almost exactly my code. Oh, what's this? This is just some bad syntax, I think. Okay. Honestly, this problem is pretty straightforward, especially for like a hard problem. I thought like if it was I think there was another problem about like cars in traffic or something, and you got to figure out the speed. They all have like different speeds and whatnot. Those kinds of problems where you actually have to find their end position is are they're usually a lot harder. But in the end, you would still use a stack, except you would use it as like a monotonic stack, I think. Let's see. Yeah, stack, blah, 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 blah. Okay, let's look at similar questions. Asteroid collision. I'm not sure about that, but there's definitely a lot of like collision problems. Let me just see. What? Oh. Are these listed as two different problems? Hmm. Well, there were definitely like Usico problems and stuff that were very much along this vein, but harder because you had to keep track of the position at the end. Yeah, if we had to keep track of position in the end. Yeah, I guess actually it wouldn't be too much harder because it's still just like the two robots. Like you know what's gonna collide and stuff, so you still just compare to the top element in the stack, but you keep track of the positions after. Yeah, but if it was different speeds, that would be like an absolute wreck. But that would also go back to like the monotonic thing. For example, ooh no, no, that's just a wreck. Cause like if they're going in different directions as well and they're different speeds, yeah, that'll be like a pain to solve. But at least that's not the problem. Let's hope companies don't use that in their interviews. But yeah, hopefully you found this problem helpful or like this video helpful. And that was our first hard problem this month. So looking forward to the next hard problem. And I'll see you guys tomorrow. Bye bye.